In this video, I want to do a bunch of examples involving exponent properties. But before I even do that, let's have a little bit of a review of what an exponent even is. So let's say I had 2 to the third power. You might be tempted to say, oh, is that 6? And I would say, no, it is not 6. This means 2 times itself 3 times. So this is going to be equal to 2 times 2 times 2, which is equal to 2 times 2 is 4. 4 times 2 is equal to 8. If I were to ask you what 3 to the second power is, or 3 squared, this is equal to 3 times itself 2 times. This is equal to 3 times 3, which is equal to 9. Let's do one more of these. I think you're getting the general sense if you've never seen these before. Let's say I have, I don't know, 5 to the 7th power. That's equal to 5 times itself 7 times. 5 times 5 times 5 times 5 times 5 times 5 times 5. That's 7, right? 1, 2, 3, 4, 5, 6, 7. And this is going to be a really, 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 really large number. And I'm not going to calculate it right now. If you want to do it by hand, feel free to do so or use a calculator. But this is a really, really, really large number. So one thing that you might appreciate very quickly is that exponents increase very rapidly. 5 to the 17th would be even a way, way more massive number. But anyway, that's a review of exponents. Let's get a little bit steeped in algebra using exponents. So what would 3x, let me do this in a different color. What would 3x times 3x times 3x be? Well, one thing you need to remember about multiplication is it doesn't matter what order you do the multiplication in. So this is going to be the same thing as 3 times 3 times 3 times x times x times x. And just based on what we reviewed just here, that part right there, 3 times 3 3 times, that's 3 to the third power. And this right here, x times itself 3 times, that's x to the third power. So this whole thing can be written as 3 to the third times x to the third. Or if you know what 3 to the third is, this is 9 times 3, which is 27. This is 27 x to the third power. Now, you might have said, hey, wasn't 3x times 3x times 3x, wasn't that 3x to the third power? Right? You're multiplying 3x times itself 3 times. And I would say, yes, it is. So this right here, you could interpret that as 3x to the third power. And just like that, we stumbled on one of our exponent properties. Notice this. When I have something times something, and that whole thing is to the third power, that equals each of those things to the third power times each other. So 3x to the third is the same thing as 3 to the third times x to the third times x to the third, which is 27 to the third power. Let's do a couple more examples. What if I were to ask you what 6 to the third times 6 to the 6th power is? And this is going to be a really huge number, but I want to write it as a power of 6. And let me write the 6 to the 6th actually in a different color. 6 to the 6th times 6 to the third times 6 to the 6th power. What is this going to be equal to? Well, 6 to the third, we know that 6 times itself 3 times. So it's 6 times 6 times 6. And then that's going to be times, the times here is in green, so I'll do it in green. Or maybe I'll make both of them in orange. That is going to be times 6 to the 6th power. Well, what's 6 to the 6th power? That's 6 times itself 6 times. So it's 6 times 6 times 6 times 6 times 6. Let's see, that's 5. Then you get one more times 6. So what is this whole number going to be? Well, this whole thing, we're multiplying 6 times itself how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9 times, right? 3 times here, and then another 6 times here. So we're multiplying 6 times itself 9 times. 3 plus 6. So this is equal to 6 to the 3 plus 6th power, or 6 to the 9th power. And just like that, we've stumbled on another exponent property. When we take exponents, in this case, 6 to the third, the number 6 is the base. We're taking the base to the exponent of 3. When you have the same base, and you're multiplying two exponents with the same base, you can add the exponents. So if I have, let me do several more examples of this. If I have, let's do it in magenta. Let's say I had 2 squared times 2 to the fourth times 2 to the sixth. Well, I have the same base in all of these, so I can add the exponents. This is going to be equal to 2 to the 2 plus 4 plus 6, which is equal to 2 to the 12th power. And hopefully that makes sense, because this is going to be 2 times 2, 2 times itself 2 times, 2 times itself 4 times, 2 times itself 6 times. So when you multiply them all out, it's going to be 2 times itself 12 times, or 2 to the 12th power. Let's do it in with a little bit more abstract way, using some variables, but it's the same exact idea. What is x to the squared, or x squared, times x to the fourth? Well, we could use the property we just learned. We have the exact same base, x. So it's going to be x to the 2 plus 4 power. It's going to be x to the 6th power. And if you don't believe me, what is x squared? X squared is equal to x times x. And if you're going to multiply that times x to the fourth, you're multiplying it by x times itself 4 times. X times x times x times x. So how many times are you now multiplying x by itself? Well, 1, 2, 3, 4, 5, 6 times. X to the 6th power. Let's do another one of these. The more examples you see, I figure the better. So let me do the other property just to mix and match it. Let's say I have a to the third to the 4th power. So I'll tell you the property here, and then I'll show you why it makes sense. When you have something to an exponent, and then you raise that to an exponent, you can multiply the exponents. So this is going to be a to the 3 times 4 power, or a to the 12th power. And why does that make sense? Well, this right here is a to the third times itself 4 times. So this is equal to a to the third times a to the third times a to the third times a to the third. Well, we have the same base, so we can add the exponents. So this is going to be a to the 3 times 4, right? This is equal to a to the 3 plus 3 plus 3 plus 3 power, which is the same thing as a to the 3 times 4 power, or a to the 12th power. So just to review the properties we've learned so far in this video, besides just a review of what an exponent is, if I have something, let's say I have x to the a power times x to the b power, this is going to be equal to x to the a plus b power. We saw that right here. X squared times x to the fourth is equal to x to the sixth, 2 plus 4. We also saw that if I have x times y to the a power, this is the same thing as x to the a power times y to the a power. We saw that early on in this video. We saw that over here. 3x to the third is the same thing as 3 to the third times x to the third. That's what this is saying right here. 3x to the third is the same thing as 3 to the third times x to the third. And then the last property, which we just stumbled upon, is if you have x to the a, and then you raise that to the bth power, that's equal to x to the a times b. And we saw that right there. A to the third, and then raise that to the 4th power, is the same thing as a to the 3 times 4, or a to the 12th power. So let's use these properties, to do a handful of what we could call more complex problems. So let's say we had, I don't know, let's say I want to do something a little bit. Let's say we have 2xy squared times negative x squared y squared times 3x squared y squared. And we wanted to simplify this. Well, a good place to start. Let's see, maybe we could simplify this. This you could view as -1 times x squared times y squared. So just this part right here, if we take this whole thing to the squared power, this is like raising each of these to the second power. So this part right here could be simplified as -1 squared times x squared squared times y squared. And then if we were to simplify that, -1 squared is just 1. X squared squared. Remember, you can just multiply the exponents. So that's going to be x to the fourth y squared. That's what this middle part simplifies to. And let's see if we can merge it with the other parts. The other parts, just to remember, were 2xy squared and then 3x squared y squared. Well, now we're just going ahead and just straight up multiplying everything. And we learned in multiplication that it doesn't matter which order you multiply things in. So I can just rearrange. We're just going and multiplying 2 times x times y squared times x to the fourth times y squared times 3 times x squared times y squared. So I can rearrange this, and I will rearrange it so that it's in a way that it's easy to simplify. So I can multiply 2 times 3, and then I can worry about the x terms. Let me do it in this color. Then I have times x times x to the fourth times x squared times x squared. And then I have to worry about the y terms. Times y squared times y squared times another y squared times another y squared times another y squared. And now what are these equal to? Well, 2 times 3, you knew how to do that. That's equal to 6. And what is x times x to the fourth times x squared? Well, one thing to remember is x is the same thing as x to the first power. Anything to the first power is just that number. So, 2 to the first power is just 2. 3 to the first power is just 3. So what is this going to be equal to? This is going to be equal to, we can add, we have the same base, x, we can add the exponents. X to the 1 plus 4 plus 2 power, and I will add it in the next step. And then on the y's, this is times y to the 2 plus 2 plus 2 power. And what does that give us? That gives us 6 x to the 7th power y to the 6th power. Now I'll just leave you with something that you might already know, but it's pretty interesting. And that's the question of what happens when you take something to the 0th power. So if I say 7 to the 0th power, what does that equal? And I'll tell you right now, and this might seem very counterintuitive, this is equal to 1. Or 1 to the 0th power is also equal to 1. Anything to the 0th power, any non-zero number to the 0th power, is going to be equal to 1. And just to give you a little bit of an intuition on why that is, think about it this way. Think about it this way. 3 to the first power, so let me write the powers. 3 to the first, second, third, we'll just do it with the number 3. With the number 3. So 3 to the first power is 3. I think that makes sense. 3 to the second power is 9. 3 to the third power is 27. And of course, we're trying to figure out what should 3 to the 0th power be. Well, think about it. Every time you decrement the exponent, every time you take the exponent down by 1, you are dividing by 3. To go from 27 to 9, you divide by 3. To go from 9 to 3, you divide by 3. So to go from this exponent to that exponent, maybe we should divide by 3 again. And that's why anything to the 0th power, in this case 3 to the 0th power, is 1. See you in the next video.